Are we going?
It's going.
All right, video's going. Hey, today we're going to be doing finding rational solutions of a polynomial equation. And what we're really looking for is a solution is a zero, right? And a zero is a what?
X-intercept.
X-intercept. So zeros and solutions and x-intercepts are the exact same thing. We're going to look at this and we're going to find our zeros for this first one. All right. So we can see these factors in order to find our zeros, and you don't have to actually do the work. I say each of my factors equal to zero, right? So my first zero would be
-2.
You could write -2. I think you can all see that. What's my next zero? 1. So comma 1, and my next zero is going to be -3. And in order, I want to show you something that we need to recognize. So we're going to do this twice. We're going to go ahead and we're going to FOIL this out. We're going to distribute it out. We're going to put this in standard form. So if you could put f of x down here equals x plus 2 times x minus 1. We're just going to write the whole thing. So x plus 2, that's plus 2. We're going to use the actual factors. X minus 1. And then x plus 3. And let's go ahead and put that in standard form by multiplying all those factors together. So I'm going to walk through this first part with you, right? If we did these two. Are you guys good adding the inner and outer, you believe?
Yeah.
So my first is x squared. So put that in parentheses down below. We've got x squared. Now let's go ahead and take the inner and outer. My inner would be 2x. My outer would be -x. Those would add to x, so plus x. And my last would be 2 times -1, which is -2. And now we're going to drop down that x plus 3. And we're going to do this twice so we can notice something. All right? We're going to drop down that x plus 3. All right? And we're going to FOIL that out too. So just do one at a time, right? X squared times x is x cubed. X squared times 3 is 3x squared. Right? Going to the next one. X times x is x squared. X times 3 is 3x. -2 times x is, and then -2 times 3 is 6. Cool. All right. So if you go ahead and add those, we'll get f of x is equal to, we got x cubed plus 4x squared. What is that? Plus x and minus 6. And in the interest of time, I'm going to go right to the next one. So let's keep going because I can only post a certain length of video. So I want to make sure that this is posted because we're going to talk about this. We're going to talk about stuff we see. Everyone good? What if I multiplied that to, what if I set those to 0? What would the factor be here? -3/2, right? Subtract 3, divide by 2. So one of my zeros, right? One of my zeros for that one is -3/2. What's my next one? 5/4, right? Add 5, divide by 4. And the last one is? 1/6. So let's go ahead and write that down below again, and we're also going to still put that in standard form. So we got g of x down here, and we're going to say equals 2x plus 3 times 4x minus 5, and so on until we have that written down. All right. Oh, that is coming perfect. Your handwriting's so beautiful. I'm glad you're doing it and not me. All right. So hopefully we can do the same thing. Hopefully we can figure out the inners and outers. Our first one is 2x times 4x, which is 8x squared. Let's go ahead and take care of inner and outer together. So my inner is how much?
9.
12x, right? 3 is that's a 3, right? So 12x, and my outer is -10x. So 12x and -10x make 2x, right? And this last one, 3 times -5 is -15. And we're going to do the same thing. We're going to multiply it through. Again, we're going to try to keep our pace. All right. So 8x squared and 6x? 48x cubed. All right. 8x squared and -1? -8x. Go to the next one. 2x and 6x are? 12x squared. 2x and -1? -2x. -15 and 6x? -80, I believe, x. Let's see, 30, 50, 80, right? It's 80, isn't it?
Wait, it says 90.
Oh, it is 90. It's totally 90. Thank you. Catching me. All right, and the last one is what? Plus 15. If we add those, what do we get? We get 48x cubed plus 4x squared minus 92x, I believe, plus 15. All right. So I want you to be able to see these two right here. So will you pull this up so we can kind of see it at the top? And let's talk about this. All right. So look at a relationship between the zeros of each function and the coefficient of its standard form. All right, the zeros and the coefficients. So I want you to look at a relationship between the zeros and the coefficients. So if you look over here, right, I've got coefficients here, right? What do we got? We got zeros, -2, 1, and -3, right? And I've got zeros over here, -3/2, 5/4, and 1/6, right? And we're going to ask two questions. We're going to ask, in general, how are the zeros of the polynomial function related to the standard form? So, if you look at it, I want you to focus just on the numerators. What are the numerators over here? -3, 5, and 1. Specifically, right? Specifically, I want you to look at two numbers on both ends. I want you to look at the 48, right? And I want you to look at the 15. So what do you notice about the numbers, numerators, and denominators, and how they're related to, well, how about 15? Either the numerators or denominators. How are they related to 15?
Oh, yeah, 3 and 5.
So 3 and 5 equal, if you multiply them together, they're 15, right?
Yeah.
Right? So what are they of 15? They are
Factors.
factors. So we've noticed this. We've noticed that the numerators are factors of the constant. Does that make sense? So the numerators are factors of the constant. All right. Could we say the same over here? Could we say -2 and -3, or 2 and 3 are factors of 6?
Yeah.
Does that make sense in both? So in both cases, the numerators, right? The numerators are factors of that constant right there. How about the denominators? What's the denominator here?
1.
What's the denominator here? 1. What's the denominator here? 1. How does that relate to my coefficient of 1?
There's 3.
They're factors. It actually is 1, isn't it? How about the denominators over here? What do we got?
48.
2,
4.
4, and 6. How do they relate to 48?
They're factors.
They're all factors, right? So the numerators are factors of the constant, right? And the denominators are factors of the leading coefficients, all right? So the denominators are factors of the leading coefficient. All right. All right. Oh, let's see if we can scoot up just a little bit. There we go. That's perfect. That's perfect. All right. If you use the zeros, you can rewrite this factored form. All right. Does everyone see that factored form was the first equation we had on the right up top? Do you guys agree that's the same thing?
Yeah.
All right. If we use the zeros, we can rewrite it. My question is this. These are the same term, and in the interest of time, I'm going to let you know that they're the exact same thing. What's the zero? What's the first zero here? -3/2, right? What's the first zero here? 5/4. What's the first zero here? 1/6. If I went over here, would you agree this is still -3/2?
Yeah.
How would I solve this? I would, tell me, Andrew.
Subtract 3 divided by 2.
Oh, I hope I don't get in trouble. Andrew's mom, I'm not saying his last name. Right? Subtract 3 and divide by 2. All right? So how does this relate to this? Yes?
It's the exact same thing.
Exact same thing. How would I turn this into this? Sir?
Multiply by 2.
Multiply by 2, so the denominator now becomes the
Coefficient.
leading coefficient. So what is the relationship? Well, if you take the first term, just write this, the denominator is the same as the leading coefficient. And hopefully we're going to get that within a 15-minute time frame. How are we doing up there? How's our time on that?
It's 8:59.
Oh, we're doing great. All right. The denominators are the same as the leading coefficient. All right. We're getting ready to talk about something. All right. This is eventually going to be called the rational root theorem. It's going to help us factor higher degree polynomials when we're not given a root. And that's what we're getting into. So the denominator is the same as the leading coefficient. We're going to pause. We're going to post this. Will you stop that?